Awesome. Hey, everyone. GraphQL Madrid Meetup. Super excited to be doing the third edition of this. And Carlos was very generous to let me kick this off. We'll be obviously missing his lovely presence, but I'm super excited to be hosting this month's edition. I'm Vish, and I'll be hosting this. First, I want to start off by mentioning our awesome sponsors. So say hello to Sarah.
Hello, everyone. My name is Sarah Renaud. I'm coming at you from Sylvania, Ohio. I am a marketing manager over at This.Labs. So a little bit about This. So we have two distinct arms of our organization. So at This.Labs, our biggest focus is partnering with enterprise organizations. And we specialize in mentorship, consulting, training, and staff augmentation. So if you want more information about that, you can get a hold of us at this.labs.com, or you can just drop us an email at hi@this.co. And over at this.media, we are really super passionate about creating an inclusive web. So we do that through our free developer resources and then keeping up with the evolution of the web platform. You can get more information at this.co. We have a ton of articles, podcasts, videos, and we host online meetups just like this. So including our GraphQL meetups, we just got done with JavaScript Marathon on Wednesday. We're back next month. We actually have 2 GraphQL sessions next month. October 28th, check out the session descriptions at javascriptmarathon.com. And then coming up soon, October 6th, GraphQL Meetup. We have a monthly meetup with Moon Highway. They're actually doing a really fun session this month called Tech People Talking About Non-Tech Things. So that's October 6th. Check out the description at graphql-meetup.com for more details on that. And I'm just so excited to be here. And thank you guys for having us. And I will slide things over to Vish.
Awesome. Thank you so much. Wow. All the time that Sarah was doing that intro, I was just wondering, how does she remember all of that? Wow. Great job. And I love how the Dis.dot folks are giving back to the community using all those resources. So yeah, super excited to be hosting this meetup. And let's get started without further ado. This month, we have another really cool lineup of speakers. And first off, we're starting with GraphQL Transformation by Alex. So take it away, Alex.
Thank you. Thank you very much. Thanks a lot for having me here, GraphQL Madrid, or, we say Madrid, but it's probably all over the world, hopefully watching us. So thanks a lot for having me here today. And we're going to be talking about GraphQL Transformation, which is probably a term you have not heard because it's something that I kind of, it occurred to me thinking about GraphQL. And I'm going to be talking about, we'll be doing 4 different things, which we'll start with the GraphQL. We'll talk about change, and we'll see some examples, and there will be some Q&A at the end. So let's move on. A little bit about myself. I do love JavaScript. That's, a reality. I love JavaScript so much that I always introduce myself using JavaScript. I also love a bunch of other things like, React, GraphQL, testing, lean startups. And of course, don't get me wrong, it's not that the actual order that I, love things. I always have to say this because she thinks I'm always obsessed with JavaScript and technology, but it's not true. Half true. So what do? I work for Lean.js, and where I help companies to adopt cutting-edge web modern technology with confidence and incrementally. So if you want to reach out, you can connect to us using Twitter, or any, the bottom of the slides, there is also our website and Twitter. So we're going to be talking about GraphQL and change. And I think it's something very interesting because I've been involved with GraphQL for over 3 years. And I heard a lot of things about GraphQL and a lot of cool things. And I've tried to convince companies and people that they should use GraphQL. So I'm going to share with you a little bit some kind of learnings and experiences and things that work and didn't work, and why I think they didn't. So first, very quickly, I don't have to say this, but I will say, what is GraphQL? In a nutshell, GraphQL is a typed query language. I always say, if you don't like types, if you're one of those TypeScript haters, you probably don't like GraphQL because it's all about types. But today, I'm not here to talk about what GraphQL is. I want to talk about when, I want to talk about who, and also how. So then, is just GraphQL actually going to transform anything? Right, because I always thought at the beginning, some people say, and even myself, like, oh, GraphQL is great, it's going to change so many things, it's going to make your life better, and we get super excited. But then, is it really changing things? And I think it does, and it does in two different dimensions. The first one is, it changes how we build applications, which is something we see often and we discuss from a technical perspective. We go from sending overfetching and underfetching, all those things, but it also changes the way we work. And that's interesting because it's more difficult to kind of see and measure. I want to bring a couple articles to illustrate this. This article you might have seen, it's an article where Peggy, who currently works at Apollo, was showing some improvements, and she actually could measure that they reduced 4,950 lines of code, and it was like great. It's a lot of code you get rid of, and imagine all the advantages you get from doing so. There is also this other article from Airbnb, Adam Neri from Airbnb, and he says, he claimed at the time that Airbnb moves 10 times faster with GraphQL. And when I saw this the first time, I thought like, wow, 10 times is a lot. Do they really mean 10 times? And I don't think they, like, how do they know that? Is like in the previous example, it was very clear. You could measure the lines of code and you say, no, I reduced my amount of code by this. But how do you know you're going 10 times faster? Are you measuring that over a period of time? How many projects? Is GraphQL the only variable that you change in that? It's like, how do you really measure that? So I think what they really mean is they move at a different order of magnitude. Like, it really makes a difference. And then I thought, if it really makes a difference and we can see it, that we should all be using GraphQL. But I don't see that's happening, actually, at least at the speed I thought when I saw these articles. Because to sum up about those two articles, GraphQL can help us in two different ways. One is it can improve products. It can make our products better because it reduces our code. We can focus on one thing. We have more declarative data requirements, etc. But it also changes the way we work. And that's interesting because if that was true, that we can move 10 times faster, why is not everyone using GraphQL? I wondered that for a while, and I've been thinking about it. And so I think the reason is we tend to focus on code and those things that we can measure, which are quite easy to measure. You could say, in this application before we were sending 5 requests and now we send 1. In this application, it took us like 1 second to download this data, and now we do it in half second. We had 1,000 lines of code, and now we have 100. Whatever, you can easily measure those things. But how do you measure developer experience? How can you say, from a very accurate scientific approach, like, yes, this is the kind of developer experience my team is having. Like, how is it going with GraphQL? Really good. My developer experience in my scale, it's now 7.6 compared to the previous one. And that's really good. Must be really, it's like, how do you measure that? It's really difficult. So that article is from 2007, and this article is from 2018. And it's been a long time. And I was thinking recently, how are things now with GraphQL? So when is this going to happen? Like, when are we, all of us, going to be using GraphQL? So I looked at Google Trends and I saw this, which I was a bit sad when I realized, because it seems we reached plateau. And I don't know about you, but not all my colleagues and friends are using GraphQL. So what's going on here? I don't know if it really affected this, but I thought could be. At that time, COVID came and it changed, it shaked a lot of things, and it's interesting because I honestly don't know how it affected COVID, that growth, and if there's some correlation. I don't know if there is some relationship between GraphQL and COVID, but I do believe that there is a good time now to actually embrace GraphQL, because this time everything is changing. You might be working from home. I'm delivering this all from home and not from Madrid, unfortunately. And a lot of things are changing. Some companies, they are not selling, they need to reduce cost, and they are, a bit sad, but they are laying off people. On the other hand, what I see when I speak with companies is that maybe the CTO is gone, and so the CIO is taking the role of the CTO, and that also brings the tech lead is going up in the hierarchy of the company. So things are changing, and that's an opportunity to change, because before, in the past, some companies or people would say, I'm not so sure about GraphQL, how much should I invest on this? But now things are changing, and maybe the person who actually was saying no to GraphQL, now is gone, is being fired or whatever. It's gone. So there is change. And on the other hand, companies either are kind of struggling because their business models, or they are selling less, and so they need to look for new products and new opportunities. So they need to build more things, they need to improve, they need to go faster, they need to increase velocity, and GraphQL can help that. Or some other companies, they're actually doing very well. They're selling a lot because they are doing, I don't know, like it's a supermarket online or whatever, and then you need to improve, optimize your system, and you don't have a lot of time. So that's a good combination, right? So this can be a good time to introduce change, I believe. So change is happening right now, so we can leverage that and bring GraphQL to our organizations. So now is the time to change to GraphQL. Yes, now is the time. So what do we want? We want GraphQL. Yes, who's gonna take the lead? I don't know. Like, who's gonna do that in the company, right? We get excited, but okay, how do we do it? Who should take the lead? I think that's a very important question you should answer. And I think there is an important aspect in GraphQL, that is, control is given from server to client. And that implies that people who were responsible for certain things on the back end now, or the infrastructure, they see how those things go to the front end. And what I've experienced is that they don't like it. I mean, who doesn't like that? If you're a front end, you love it, you're getting things. But if you're losing those things, it's different. And if you especially, you're bringing this new technology, this GraphQL, you're an infrastructure person, and they are gonna use that thing, but you're still responsible for the APIs, right? So if the API is down on a Saturday night, who are they gonna call? It's not gonna be the front end. So I see a lot of resistance. I see a lot of front end that they get super excited, or product teams, depending on jargon, how you call them, but kind of product engineers teams, they get very excited. The infrastructure teams, it depends on the company, which makes sense, because if you've been working with REST for 10 years, and you know how it works, you know how scalability works, how security works, you understand all those things, and now we want to bring another technology that I think most of it, the benefits go for the front end, because at the product teams, you can add more features quicker without asking the backend team, which is great, gives flexibility. But what does the backend and the infrastructure team get there? So it's normal you can see some resistance, and some say, I'm not sure I want to change. So in my experience, if you want to be successful bringing GraphQL to your little project, startup, big organization, it doesn't matter, you need to think of everyone involved in the process, because otherwise you will find resistance from people, and you don't want to do that. You want to be successful, right? So how are you going to do it? Okay, so I'm going to bring 2 examples. And before I do that, I'm going to drink a little bit of water. And then I thought, okay, we're going to bring GraphQL to some projects. I don't know, like, what is your situation, if you're a small company or big. But I thought, can we think in some sort of terms that we all understand? And I start putting things there and kind of illustrate them, and so we can discuss. It's easier to discuss when we have some common picture that we all understand. So I thought of organizing projects and developers, front end, back end, that's kind of category we hear a lot. You can also think, if you like, product teams or whatever, but kind of those two sets. And then type of project. So you're building a project, and you could say website. Website can fall into both categories. Can be front end and back end working on that. You can also have a web app, same situation. Front end, back end can work on that. A CMS, probably nowadays, I think I would put CMS on the only front end side of it. You might use a headless CMS, and I don't think you would use something like you build your own CMS or things like that. You just connect to an API. So I would put it there. Obviously, it depends on the project. It's just to organize some thoughts on this slide. APIs, I put it on the side on the right, and fine. And I thought GraphQL, I don't know if you noticed, but there's an intersection there between those two worlds. And we normally don't look at that, and we don't talk about it. And I mean, we didn't have to. Why? We always thought in terms of this is either front, back, or full stack. But there's an intersection there. And now we have GraphQL, which lies in between both. And that gives us a lot of flexibility and new things we can do. So I see GraphQL as something very powerful that it's in between the two. And I think it's important to point this out because for a reason I will tell you in a bit. But before I do that, I was also thinking in what are other things that we also use a lot, and it's very common understanding for everyone, programming languages. So you can think of how you organize your programming language, how your company or your projects organize programming languages. So what programming languages do they use? So front end dominated by JavaScript, and back end has different languages. So if you use GraphQL is just a specification. It's very abstract. You cannot use the specification, right? You need to use an implementation. Which one are you going to choose? You could use a JavaScript implementation. You could use .NET, etc. And I think there is some reflection you need to have here is if you choose .NET for your GraphQL implementation, you're probably saying to the team that takes care of responsible for the front end that they are not gonna do much on it, right? Because it's the different language. I'm a front end developer. I use JavaScript. GraphQL implementation is .NET, so that's responsibility for those .NET guys. But that's something important to bear in mind when you want to bring it to an organization is what language you're going to choose. You can choose more than one language, but that's kind of I would put some thought on that. What language is going to implement the GraphQL API or languages? Because the big question is who's going to own that intersection, right? Who's going to maintain that code? Who's going to be responsible for that? And there are different options here. It can be front end and back. It can be either of the two. And that's a discussion that, in my experience, you need to have with the team who is going to adopt GraphQL. But it should be clear who's going to own that. And again, sometimes I hear that it's kind of like, okay, this is a backend thing, but not necessarily. It's the intersection, so it touches both sides. So I think also front end have a lot to say nowadays, especially that many front ends are asked to be full stack, and so I don't see any problem by front end people also having responsibility on owning, even designing the schema of the GraphQL. Although I think it's better that the more you do between the two, the better. Like you have those two, that intersection together, or at least part of it. I'll show you some example now. And before I show the example, let's do a little recap to see where we are with these ideas I was throwing. It's time for change. So that's good. We can bring change because everything is changing. So let's take advantage of that. With GraphQL, we can build better products, but also we can build things faster, right? And that's really important. We should not underestimate how we build things with GraphQL. GraphQL is in a specification, so it's not like in React, you use React, the library is JavaScript, that's it. In GraphQL, you are going to choose a language or languages because you can also do that. And that's a reflection. You need to put some thought on that, what the language or languages that you're going to use. It's really important to identify who will own the GraphQL implementation. Because to get started with, if you identify who is going to do it, that's going to actually help you bring GraphQL to if you choose the right people, like influencers in the organization, people who want to push the idea, is going to be easier, especially in the long term. If you choose languages that there is a lot of adoption. Let us say in your organization, most of it is .NET, and there is very little of JavaScript. So or Node. If you decide to do it in Node, guess what? It's going to be quite difficult that the .NET teams get excited and help you with the adoption, which it's important if you want to be successful. And last but not least, front-end developers or the product teams, they're actually the ones who benefit the most by having GraphQL. So yeah, it's probably important to give them some voice and power in this negotiation, because sometimes even it's an API, but the front-end team can also design the schema, can also maintain the schema. So there are a lot of things they can also do. So don't forget and bring everyone on the table when you are discussing GraphQL on your teams or company. And last but not least, there can be some friction on the backend. Not necessarily. I mean, I've seen backend developers who are very excited with GraphQL, but it's kind of makes sense, because they are not going. The only thing they get is, okay, now I need to learn this new thing to improve that other person's life, which I mean is very nice. We should do those things, but sometimes we don't do that. It's like, okay, I need to learn this thing. I'm busy, and it's going to change my environment, and like, why do I have to do this? So you need to make sure you explain things properly. And I'm going to show you two examples where I try to explain or bring GraphQL to different organizations. So two projects where I was involved somehow. I decided to bring two because we don't have a lot of time. And also, I don't know, one is a small, medium enterprise, and the other one is a large enterprise. So I don't know, actually, it's going to be your case. You might be working for a startup, but you can apply, some lessons anyways. So the first case, it was a client who came to us and said it was a small, medium enterprise. They had one real estate website, kind of big in Spain, and they adopted React, and they found some problems. The website was slower, user engagement went down, probably because the performance was not as good, and well, some problems that they wanted to improve this. So we had a look, and then we look at the stack, and the first thing we saw was that there were a lot of libraries there, and there's nothing wrong with that. They do a good job, each of those tools in their own space. But for the product team, it was not easy to make changes, right? That was one problem, and you need to be very good at all those tools, and sometimes you need to change the tools. So the more tools you have, the more overhead you have, and so at some point they were like building those crazy sagas, and I was thinking like, well, you're supposed to deliver a product, not to build this state management thing, right? So what is the solution? We thought we need to simplify, and then we'll be able to move faster. So let's bring GraphQL all the things. So we did it. I'm going to tell you also what was the structure of the company. It was a small, medium enterprise, but it was part of a bigger company. It's like, this kind of a startup, or that is acquired by another company that is a group of companies, and things it's more complicated. So the team that owns that product is a small team, cross-functional team. They also do a little bit of backend, but there is a big company that has a backend infrastructure team that provides the infrastructure, the APIs, or some of it, and so the front end or the product team had to discuss and negotiate certain features and changes on the API with this backend team that was in a different city. And actually, the team that was supporting what I'm calling a small medium enterprise 5 was the backend team that was supporting the company number 5 was also supporting other websites of other companies. So the backend team is very busy. And so how do you introduce change quickly? How do you make changes on the interface quickly when you depend on that API? And making changes on the API might affect the performance. So you need to be aware of what is the structure of those teams. And we thought GraphQL was great because it would bring it would make the front end or the product team independent from the other company. Once you have your GraphQL API, the product team can have an endpoint that you can hit. You can optimize your requests, so performance will be good, and you can make changes on the UX, on the user interface. You can try different things very quickly and move fast. without having to call the backend team. So the idea was good. Now, because this was not the first product we did, I kind of learned lessons from previous projects. And so what we did is the front-end team, the product team was super happy about the idea, let's bring GraphQL. But what we did is we went to this other city and we went to the office and we spoke with the infrastructure team. That was the first thing we did. And so because we wanted to hear what challenges they had, and we wanted to minimize how much work the infrastructure team had to do. And we wanted, actually, our goal was basically, we spent 3 hours on that meeting. And I remember when we arrived to the meeting, there were those 3 backend people looking at us like this. It's like, okay, what do you want? And our goal was to convince them not only that this technology was better for us, but they didn't have to do anything. And it was not going to change anything in their life or the way they work. So the challenges, or what I would say, the checklist that they were coming and saying, okay, what about this? So they have some continuous integration system, some infrastructure. And in the short term, we didn't want to change this. So our strategy was to, maybe not the best approach, I would say, but they had some REST API, and we embedded the GraphQL API, the first version of the prototype, using that Express API that they were using for something less relevant. But for us, that was important because they could use the same pipeline. They didn't have to change anything to deploy. So if we wanted, we could deploy our GraphQL proof of concept to staging without them changing anything in the pipeline. That was really good. They were very happy about it. The second pain point they had was the CDN. They are used to that project. I think they were using Akamai, but they knew how it worked. They were happy with it. So you can't just go there and say, oh, well, we're gonna do this via post and things like that, because that was a deal breaker. So we use persistent queries, and we explain them how they work, how we're gonna use the CDN, and basically they don't have to change anything, and they were very happy with it. The third point was they were using some server-side rendering, and to do that, they were getting the data from a Java API, and they didn't want to change this. It was not like super optimal, but it was kind of working for them. So for me, I was like, well, no, this is not the way it works. We should use our GraphQL this different way, and we'll get the state in this way. But in the end, we ended up using getting that big data and from that API, because they would identify, okay, what request is this one? So this is the data for the entire page. And so they would send you a big giant JSON, all this on the server side. And so we would use that JSON to initialize the state of the GraphQL client, and then we would get the data on the client. It was a bit of hacky. I can't remember the name. It was like a schema. It was Apollo had some schema thing for initializing the state. But anyway, it worked well. The point is, even I thought it was not the best way to use that Java API for this GraphQL integration. It enabled us to do it. Performance was the same as they had, but they didn't have to change anything, because we wanted to bring value to the organization quickly and demonstrate this works, and you don't have to change the way you currently work. I'm talking about the infrastructure team. And the interesting thing about this project, and that's why I like to talk about this, is that we actually ended up not yet bringing GraphQL to the organization, and the kind of blocker came from the front end. And it's a good exercise, right? So once we convince everyone on the infrastructure, we build a prototype, we deploy to staging, and then we could extrapolate, okay, it took us this amount of time to build this, to migrate your Redux sagas into GraphQL. This is the effort it takes us to deploy. We understand how it works, everyone is happy. But then you can project and say, well, this is gonna take us, take over all these sagas and replace it with GraphQL. It's great, but it's gonna take us this amount of months. Can we afford this? And the answer of the stakeholders was no, we don't have time for this. And so they decided not to do it. And I think that's an important lesson, because like I learned the hard way in the past, like, trying to bring a technology to a project, and just because it's so cool, you try, and in the end, you're not meeting the deadlines, you're all super stressed, you're working overtime just because you wanted to bring that technology, which was super cool, but it didn't meet the deadlines of the company. So you need to be aware of that. And sometimes we are not ready for that change, and it's fine. Maybe another time. But I think that's better than bringing a technology when you are not ready. So it's good to make this exercise. First, convince, explain how things work, make sure everyone is on the same page, build some proof of concept, and then get that evidence and say, okay, I think it's not good to do it. And the interesting thing as well, after we got everyone excited, even the infrastructure team and the CTO, and when we went back and said, look, I think we should not use GraphQL, and these are the reasons. It's great, but it's going to take this amount of time, and I'm not sure. Do you want to do that? And they said no, and they're actually very happy, because in the end, the CTO didn't care about GraphQL. They wanted more performance and they wanted better engagement. They didn't buy GraphQL, so that was a good lesson, and they were happy in the end. So the other use case, it's a project. It's something that I'm actually involved right now. So I don't have what's the end of the story? I don't know. But I can tell you, I think it's a nice exercise. This is a very large organization. And in the end, it's not so different compared to the other one, because in the end, the other one was a small company in a bigger one, some sort of. But you can think of, you have a big organization, and I just realized I'm a bit short of time, so I'm going to be a bit quick now. So typically, big companies, they organize themselves. They can have domains, and so each domain might have a core team, and each core team, its domain has kind of what I would call the peripheral teams, right? You can have supplies or customer service or users, so they take care of different parts of different products. And the core team might, be responsible for infrastructure, some Kafkas or things that the other teams use to deliver their products. So interesting thing is that the core teams, in my experience, they tend to be a lot of backend engineers, and they have a lot of experience, right, in REST APIs, and they've been doing this for many, many years. So what happens is that because they are very senior and they are very experienced in REST, and they're responsible for many things, they tend to be a bit resistant to adopt GraphQL. So they're a bit like, I'm not sure, I'm a bit hesitant about this. So if you want to bring GraphQL to a big organization, or if you're a part of a big organization and you want to be GraphQL, I'm not sure that's a good starting point. I mean, as I said before, you need to try to have everyone on board, and you should talk with them. But in the end, there is risk, and in doing that, because if it doesn't work, it's going to affect a lot of things. So you probably don't want to start by that. On the other hand, you can think of these peripheral teams. Some of them are less experienced, right? Might be more junior because they don't have to be as experienced as the core team in general. You can identify also what are the teams that they might be already interested in GraphQL, right? They might be talking about it, they might be excited. And you can also find projects that have less risk. And so they also will have less impact in the organization, but you can start with something small and then grow from there. And the other interesting thing is, because you can think, if I go back, you can choose one team that is delivering one product. And so that team can improve the communication between front and back and all that stuff. And that's really good. There is value in that. But at the same time, that team might communicate with other teams, so that you can also improve if you are able to. One team that is adopting GraphQL and is working well can influence another team that can also, because team A and team B, like customers and users, those teams talk to each other. By one having GraphQL will influence the other one to bring GraphQL as well. So I would like to finish with this. I think it's we get very excited about technology. I do love GraphQL. I hope that is going to transform all our applications and the way we build apps. But it's really important that we are aware of everyone that is involved in this change. So sometimes we get very excited, but some people might have families that are more busy, or they work on projects that have more deadlines, or they've been working in technology that is more legacy, and there are different stories. And if you want to be successful bringing GraphQL to your company or to convince your colleagues, you need to be really aware of what is the interest in bringing this to the whole group. and they make sure that they understand what are the risks involved in this situation. And then I wish you good luck in your transformation. Thank you very much. That was my little story for today. If you have any questions, we are going to have some Q&A now. And you can also follow me on Twitter or send us an email at leanjs.com. You can contact us through the website as well. Yeah. Is there any questions? Hope you like it.
That was so awesome. I feel like this is going to be my new favorite talk. Thank you so much for that talk, Alex. That was amazing. I do this thing where when I'm listening to a really cool talk, I love to take pictures of the slides that I really like. So I started off by clicking one or two pictures, and now I think my desktop is full of pictures from your
Nice.
slides. So that was
Thank you.
awesome.
Thank you.
I really like the part where you started from GraphQL is not what, but it's rather it's why, how, and when. So that was,
Thank you very much.
let's see if we have any questions. Yes. Someone says awesome talk. That was yes, absolutely. That was amazing. I also the way you ended, I mean, the entire talk was like in a great flow and I loved it. But my favorite part would be that like if you talk about the non-technical aspects, I loved how you brought in the idea that even just considering GraphQL in your organization, it takes a lot of thought. Like keeping GraphQL aside, it just takes good communication between your team members and you, and it's very important to understand what your team needs. If there's like a difference of opinion, and just get everyone on the table and communicate. So I love that.
Absolutely. Even if
Love
you
that.
don't think, yeah, even if you don't think that they are super interested in it, it's always to listen to everyone.
Absolutely, yeah. And the meme format. Always here for memes. Okay, awesome. We have a question from Nader. How can I make sure that GraphQL will help our project regarding its speed?
So I think, I mean, it's going to be a very general answer, but that's what I always like. If as a good engineer, when you start some change, how do you do it? You always want to identify the part that has less risk and can bring more value. Then do something very, very small, try it out, because sometimes like we don't know, like until you try, you need to get evidence, and then you can see. You can say, okay, we're going to select this feature. And I remember for the project that we tried, that they decided not to do it, we went for the links at the footer of the website, some related links or some sort of small links. And so we got that component. We built a very small schema, like 2 types, and we use the client. We put the data, we deploy, and it was low risk because those were static. They didn't change much on the website. It was not a lot of value, but it was some value in the sense that we could say, look, in 1 week, it took us 1 week to build that. In 1 week, we can deploy this to staging. Look at this, amazing, GraphQL. And so, okay, it's not super fancy, but then you can get some value, and then you can say from this, okay, let's try something else more complicated. And so and you will gain after that. Someone will say, okay, let's allocate 2 weeks or 1 month, and see what you can do, and then you can grow. But you want to go incrementally and always demonstrate value as soon as possible. And when I say value, for me, is make sure that can go to production, right? And then if they decide not to deploy, that's a different story. But make sure they could say, okay, we like this, let's deploy that to production. Small steps, baby steps.
That's an excellent answer. Yeah, I like how you said that. Just to understand the value of GraphQL, especially in production apps, it's important that you start off incrementally, especially with smaller projects. So yeah, that was an excellent answer. Thank you.
Mm-hmm.
Do we have any more questions? Also, Alex will be happy to answer any more questions if we get them in the chat. And you also have their socials, so make sure that you get in touch if you have any questions. Awesome. Thank you again for the amazing talk, Alex. Moving on, we have another awesome speaker, and I'm super excited for this talk personally. We'll be learning a lot. So Caddy will be talking about GraphQL with React featuring Urko. So take away, Caddy.
Awesome. Thank you very much. I'm very excited to be here. This is actually I think it's my first remote meetup. So I'm really happy that there's a way to carry on knowledge sharing and meeting remotely from the comfort of our own home. So speaking of comfort of homes, just to give you a heads up, I actually live next to a main road, which is usually fine, but it's currently close to 6 p.m., which makes it peak traffic time. So, so I'm hoping for a quiet day for traffic, but if it gets a bit noisy, feel free to make a drinking game out of it. All right, so let's get stuck in. I'm going to talk about GraphQL with React Native, and specifically I'm going to talk about using Urko on the client side. So just quickly a little bit about me. My name's Caddy. I'm an engineering manager at Formidable. So here's a picture of me with slightly longer hair. So Formidable, if you've not heard of it, Formidable is a JavaScript consultancy. It's US and London-based. And we pretty much build things in JavaScript. So anything to do with JavaScript on the front end, back end. So we do React, Node.js, React Native, and we're really, really big on GraphQL and open source. So Urko, the library that I'm going to be talking quite a bit about today, is actually part of Formidable open source, which is why I know especially much about it. All right, so just to quickly go over the topics and what I'm going to be covering today. That's one. So I'm going to start with just talking about Urko and what is Urko all about. You've probably heard of it and maybe have some idea of what it is, but I'm going to explain how it fits into the GraphQL ecosystem. And then the following topics are kind of topics around Urko. So we're going to talk about exchanges, which is a way to extend Urko. We're going to talk about caching, the different opportunities there. We're going to talk about offline support, which is especially important when you're building mobile applications. Then we're going to talk about everyone's favorite topic, authentication. And then we're going to cover dev tools, so what kind of options we have for Urko. And finally, just a quick shout out to where the community is. All right, so let's start with where does Urko fit into the kind of GraphQL ecosystem. So say you're starting a new React or a React Native project, and the API that you will be using is in GraphQL. What you want to do then is you want a GraphQL client because you want some way to interact with the API that's kind of convenient. There are currently kind of 3 options in the community for this purpose. So we have Relay, we have Apollo client, and we have Urko. So Relay is kind of the first GraphQL client, so it's by Facebook. It's kind of an outlier compared to the other 2. The API is quite different. And personally, I will admit I've never actually used it in production, although I've looked into it. So during this talk, I'm mostly going to be focusing on Apollo client and Urko. So what is Urko all about? Well, Urko, there's no way around it. It's kind of an alternative to Apollo client. So the history of it is it was first launched around 2 years ago, while Apollo client was almost the only GraphQL client. It was kind of the main go-to GraphQL client for everyone. And there wasn't really any like serious competition. And Apollo client at the time was having some problems. Well, not problems, but like some things that people weren't too happy about regarding the speed and the API. So then Urko was kind of built to be a really lightweight and fast, extensible GraphQL client specifically for React and React Native. And that's why it's kind of ended up being very similar to Apollo client because we kind of ended up with Urko kind of ended up taking the best parts of Apollo client and just extending them a little bit. And I think that's actually been really good for the community because any one client having a monopoly is kind of detrimental to improved user experience, but having more opportunities in the same space means that all the libraries separately have an incentive to improve. And also, like if you compare Apollo client to 2 years ago to now, I think both Apollo clients and Urko have kind of ended up influencing each other in a positive way. So I actually asked Phil, who's a core maintainer of Urko, for a quote for what Urko is. And he said, "Our place in the ecosystem was to challenge existing solutions and to be flexible enough to adopt new ideas." So it's all about flexibility and improvement. Now, before we get stuck in, I just wanted to briefly tell you about my experience using GraphQL, specifically with React Native. So the first time I used GraphQL, I think it was actually early 2017. And it was just a small project I did like a Lambda function with GraphQL. So that was like during the start of the GraphQL hype train. But the first real project that I did in GraphQL was in October 2017. So this was a whole application. It had like this fully fledged GraphQL API. It had the React Native app, and then it had a React frontend as well. So both of them were using GraphQL. And for the frontend at the time, we were using Apollo client. And since then, I've had various projects in React Native with and without GraphQL. But when using GraphQL, I've always ended up using Apollo client because that was the main thing, and that's what the clients wanted. And but this all changed later this year when I started a brand new greenfield project, and the client was very happy for us to use Urko. So that was my first actual production experience using Urko, which was very exciting. And I just wanted to kind of share my knowledge around how Urko compares to Apollo client, and kind of like the kind of up to like things around the Urko ecosystem that you can use. All right, so let's look at how you get started using Urko and Apollo. So I've actually copy-pasted the Getting Started guide from both of the websites, just so you could compare them. And you can see that they are very, very similar. So if you already used Apollo, you can pretty much straight away understand how to use Urko. So if you look at Apollo first, what we do is we obviously install the client. Then we create the client using Apollo client, and we pass in two things, which is the minimum client. We pass the URL for the GraphQL endpoint, and then we also pass in the cache. So the cache is initialized, imported and initialized separately. And then we have an Apollo provider, which is also exported from the library. And we wrap our whole application in the Apollo provider and pass in the client. So going on the right to Urko, so let's look at how Urko does it. You'll see that it's very similar. So we create the client. One thing that's different is that you don't have to pass in a cache yourself. So Urko does come with a cache. It comes with document cache by default, but you don't need to pass it in. So the minimum client only has one variable, which is one parameter, which is the URL. And then the rest of it is pretty much the same. We have a provider, we wrap our whole application in a provider, and we pass the client into the provider, so it will be accessible within the application tree. All right, let's look at how we query data. So going with Apollo again, so we would use a hook. So hooks are the cool new way to, well, not new anymore, but it is the go-to way to do side effects and handle state in function components in React and React Native. So we have a use query hook, which is exported from Apollo client, and we pass into it a GraphQL query string, but which needs to be wrapped in the GraphQL template tag. So the tag converts the string into the GraphQL AST. So we pass that in, and what we get as a return, we get an object that has all the metadata for the request that's currently in flight. So we have whether it's loading, if it's errored, and once we get the data, we get the data. So going on the right again for Urko. So one thing you'll notice that's different is we don't need to wrap the query in the GraphQL tag. That's actually done within the library. So all we need to do is pass in the template string. The API is a little bit different in that we pass in an object with a query key rather than like a top-level argument, but the idea is the same. And the other thing that's different is rather than returning an object, it actually returns an array And response in this case is an object that has fetching, error, and the actual data. And this is done because, I'm not showing it here, but the second array item in that array is actually a function that allows you to refetch that query. All right, let's talk about exchanges. So exchanges are a very, very central concept in Urko. They are a series of operations that transform the input stream to the output stream. This is like the documentation description. But basically what it is, like if you think about what a GraphQL client is you have a request, you say, I want this data, and then like things can happen to this request until we actually fetch the data. The data comes back and we give it to the client. And then during this kind of data flow, we can still interact with the data. And this is what an exchange is. If you were to compare it to something in the Apollo world, they're actually quite similar to Apollo Link. But they go a little bit further than that because in Urko, literally everything's an exchange. In fact, so Yovi, who's also a core maintainer of Urko, so I asked him for a quote about Urko, and he went with that Urko is so extensible that even the cache is an exchange, which kind of goes to show just how central a concept exchanges are. So how do they work? Basically, so I have some pipes here, and these are going to demonstrate the kind of out-of-the-box exchanges that you get with Urko. So when you just instantiate the client just with the URL, you get 3 exchanges that are already applied. And this is what we're going to look into. So on the left, we have use query. So this is the hook that we've called. Now, this is going through all these 3 exchanges, and we get data at the end. All right, let's look at each of them. So the last one that we have, so this is always the last exchange in the exchanges array, is called fetch exchange. And what this does, it pretty much does the heavy lifting of the actual data fetching. So it takes the query that you've given it, that you requested, uses the fetch API to fetch it from your GraphQL API, and then adds the results to the output stream, and then they get sent as the query result. On the other end, the other exchange that we have is called dedupe exchange. And what this does is it removes the duplicates from pending operations. So for example, in React, this will happen quite frequently. If you have a React render tree, you have several use queries and they query the same, exactly the same query. Then you're going to end up with multiple pending queries that do the same API request, which is redundant. So what this does, it removes the duplicate queries. But once data returns, then both of the use queries will get the result. And finally, we have a cache exchange. So this is the default caching logic that comes by default. It's called document caching. It's quite a lightweight, simple cache. Now, if you're kind of following along, you might find the arrows a little bit confusing, because if you think about how a cache exchange works, is it has 2 jobs, doesn't it? Firstly, it needs to check, is this thing in the cache? And if it is, just return it, if that's what's desired. And secondly, it needs to also save the results in the cache after they've been returned. So how can it be in the middle after the fetch exchange? Well, in order to explain that, I actually need to do a little update on how the actual data flow works in exchanges. So this is a more accurate representation of how the data works, a data flow works. So from a use query, we go into the dedupe exchange. So this is the actual raw query that, like, the GraphQL string. We go into the dedupe exchange. Dedupe exchange looks at whether this query already exists and removes it if it doesn't. Then we go to the cache exchange, which does this thing. Then we go to the fetch exchange. So now this does the actual heavy lifting, does the API request. This is why this exchange always has to be at the very end. Now this comes back, and then instead of returning the data straight to the front end, what it actually does is it goes back through the cache exchange, and then through the dedupe exchange, and then finally out the other end. So every exchange has 2 opportunities to update the data, once when it's the query and once when it's the result. So this is like a bit unusual, It might take a little bit of time to wrap your head around it. But if you figured it out, you can write your own custom exchanges. So you can modify any of this. You can remove any of the exchanges. You can replace them, and you can put your own custom exchanges at any point in this exchanges array, as long as they follow the API. And now you might wonder, how does this magical API work? Like, how do you have an exchange that can update the data in two places? Well, it's all doing like using streams. So this is an example of a custom exchange that's a no-op exchange. So this means that the data passes through it, but the data isn't being modified. So if you see a look at the bottom, we have the exchanges array, and we have the dedupe exchange, the no-op exchange, and then the fetch exchange. So if you look at what this does, so we get the client and we get the forward function, right? And then the operations here, the forward operations. So these are before they've been fetched. So this is the query that the user has. So in this exchange, I could update these operations. I could add some headers, or I could move operations. And if I want to, I can also not forward it if I don't want to. But if I want to pass it on to the next exchange, so in this instance, if I want to pass it forward to the fetch exchange, I call forward with the operations. And the operation results is what comes back after the fetch has been done. So this is the actual result that came from the API. And if I want to, I would be able to update this result as well. And finally, we return the operation result, and then this gets passed into a dedupe exchange. So it can be a little bit much when you get started, but actually once it clicks, it's very satisfying. All right, so why might you want to implement your own exchange? Well, one of the common things is authentication. And if you're anything like me, implementing authentication, you have this like scared, oh no, please not me look, because it's always a hassle. So in my last project, when I used Urko, I built a custom exchange to handle authentication. So we had authentication logic where we need to fetch the token from async storage. We need to add it to the headers. We need to check if there's been an auth error, and then we need to trigger the refresh logic. So it was quite complicated. And I found that authentication has always been complicated. It's never been easy. It's never just worked, regardless of how many times you've done it. I've also, when I used Apollo client, I also found it quite difficult to do it. And I found it quite frustrating that no clients kind of come with authentication built in, and why not? And indeed, why not? So as of I think 2 or 3 weeks ago, Urko has built-in support for authentication. So we published an Auth Exchange, and basically it's a really flexible API that follows the kind of usual JWT-based authentication. So it allows you to retrieve auth state from storage. So it can be async storage in case of React Native, or just local storage in case of the web. You can add auth headers, or just however you need to add the auth state into your outgoing requests. And also has built-in support for token refresh. So if your token refresh is in a mutation, or if it's a separate fetch endpoint, we can support both. And you can also track and forward auth errors. And not only that, there's also a fully fledged, very detailed authentication guide if you go to the Urko documentation, and it explains kind of the common authentication flow, and it has a step-by-step instruction of how you can go about using the Auth Exchange to add authentication to your application. So this is, I think it's one of a kind, or it's definitely a very needed addition, because I found that everyone tends to struggle with authentication. So hopefully this makes it a little bit easier. All right, let's talk about caching. Well, caching enables you to basically fetch recurring data from the cache instead of querying anew each time. This saves on network requests. It makes the experience faster. Well, I'm sure I don't need to sell anyone on caching. As I said, by default, Urko uses the document cache, which is a good cache, which is good for simple applications. the way you interact with the cache is basically on a per query basis. So per query, you can optionally pass in a request policy key, which will determine whether the data gets fetched from the cache or not. So the options here are cache first, cache network, cache only, and network only. So cache first is the is their default request policy, and what this means that it will, when you do the query, it will look in the cache to see if this exists already. If it does, just return it and don't do a network request. If it doesn't, do a network request. The other options are cache and network. This is quite a nice one because basically what this one does is if there is a request already in the cache, it returns it, but it also does a network request so that if data has changed, it will get updated in the cache and then the UI gets updated. So the user will always have something to see. And then we have cache only and network only, which are probably self-evident. Now you might immediately think, okay, but how do I invalidate the cache? Well, as with everything in Urko, it's an exchange. So there is a request policy exchange, and what this does is you can set the amount of time that you want the request to be valid. So in this case, it's 1 minute. And you can also optionally pass in a should upgrade function. So after a request is more than 1 minute old, in this case, it will check whether the request policy was cache only, and if it wasn't, it will do a fresh fetch. All right, graph cache. So I mentioned before that document cache, which is the default cache for Urko, is quite basic and it doesn't handle interdependencies. So there is an alternative cache which is much more clever, and it's called graph cache. And in order to add it to your exchanges, you install it at Urko Exchange Graph Cache, and you initialize it in the exchanges array instead of the document cache. So one of the handy things that this does is it handles cache updates after a mutation. So here in this example, we have a list of to-dos. So on the first code example here, we've got our use query, where we queried our list of to-dos. So this is somewhere else in the application, and if you're using a cache, this automatically gets added to the cache. Now, somewhere else in the application, we have this update to-do mutation, where we can update the to-do item title based on the ID. Now, the question is, after we've done this update mutation, how does the cache get updated? Well, there are a few options. So if you used Apollo client, you'll probably remember refetch queries. So they are an array of queries, query names that get refetched automatically after a mutation has occurred. So this works, but it does create quite a few additional network requests that arguably aren't necessary. And also, we already have the data, so it seems redundant to do yet another network request for it. Then the other option is to manually update the cache with the mutation results. This is another thing that you used to have to do with Apollo. So you literally created an update function so that after each mutation you have to apply this, which got very verbose very quickly. But actually, what we can do, because we're using GraphQL and it's all typed, we just let the cache handle it. So with graph cache, the cache is automatically updated with the mutation result. And the way it's done is every piece of data has a type name. So this is internal. You don't need to query it explicitly. And it needs to have an ID, which you do need to query explicitly. So what graph cache does is it matches the specific piece of data based on the type name and the ID, and then it updates all the fields. So the only thing you need to do is remember to, after the mutation, re-query the thing that got updated. You might run into a problem that I run into, which is that the data doesn't have a reliable ID. Well, in this case, you can add it manually in the cache config. So for example, here you get the parent element, and you can calculate the ID based on the parent if that's possible. But if it's not possible, you can also simply opt out of the cache for these values. So yeah, that can work as well. All right. And what if the mutation result doesn't return everything that gets updated? So I ran into that quite a few times. Well, not quite a few times, where basically the mutation can only return one thing, but sometimes in your API you change one thing, but something else also changes. So in my case, it was something on the user profile that changes when you update a completely different entity, and this entity gets updated in the cache, but the user profile doesn't. So basically what I can do here is when this particular mutation has finished running, I can take the mutation result and do whatever I want in the cache to actually update it. All right, offline support. I won't go very deeply into it right now, just because I don't have that much time. But GraphCache is set to support offline mode. So it's currently in, I think, alpha or beta. So it's kind of early days for it. But it's built to have kind of a flexible API where you can save and retrieve the data when you start the application, when you close it, and also I think there'll be some method of replaying the mutations. All right. Dev tools. Well, every good library needs some dev tools. So Urko has their own dev tools, which is quite handy. So you can use, if you're on the web, you can use the Chrome extension or the Firefox extension. But if you're on React Native, there is an Electron app, which you can launch just from the terminal. So I'm just going to show you a little bit of what it looks like. So in order to set up, surprise, surprise, it's an exchange. So the way you set it up is you install Urko DevTools, and then you add the DevTools exchange as the first exchange in your exchanges array. You don't need to even worry about it being available in production, because it automatically doesn't launch when your node enters production. And then if you're in React Native, you just go on your terminal and do npx Urko DevTools, and you will download and open the Electron app. Or if you're on the web, you just open the Chrome or Firefox extension. All right, and this is what it looks like. So this is the Electron version, but the DevTools look very, very similar. So we have 3 tabs. On the first tab, we have the Schema Explorer. So the bit on the left, this is kind of all the data that's currently in the application. So this populates itself as you kind of navigate around your screens. So on the right, we have details on the currently selected data. Then in the Events tab, this is kind of similar to the Network tab in Chrome. So you can see all the queries and mutations that your application has done. And you can see how long they look. You can inspect different kind of internal events. And then on the right, you have all the metadata about the query and the response. And then finally, we have the Request tab. So the Request tab is quite similar to GraphQL, like the GraphQL Playground, with the difference that this in itself gets run through the exchanges. So in my case, for example, I have an authentication header that needs to be added to each request. So I don't need to add it here separately as you would in GraphQL Playground, because this gets run through all my exchanges. So it's as if my application did the request, which is quite neat. All right, and lastly, around community. So excitingly, Urko community has historically been in Spectrum, but as of recently, it's moved to the discussion tabs in GitHub discussions, which is awesome. So if you have any questions, or you want to get started, or you don't know what to do, or something isn't working, rather than creating an issue, you can actually add a discussion and start something there. So it's pretty active. You'll definitely get a response. All right, well, that's pretty much it. That was my kind of drive-by explanation of what Urko is and how it works. So I've got some links here, and check it out. And if you have any questions, you can ask me directly on Twitter, or post in the Urko discussions tab on GitHub. Thank you very much.
Awesome. That was an amazing talk, Caddy. Thank you so much for that.
Thank you.
I really now, like after listening to your talk, I'm really mad at myself for not trying out, Urkel until now. But I'm gonna definitely give it a go. I love the dev tools that you have, and the playground and the events tab look very neat. So I'm definitely gonna give that a go. Let's see if we have any questions.
Yeah, it's very
Okay.
handy, especially for React Native, because like it's always such a hassle to debug anything, because you don't really have access to the same things. Only as of recently, there's Flipper, which is kind of a better debug experience. But it's really nice to have something for Urkel built in. So I ended up using it quite a lot.
Oh, absolutely. And also, you talked about authentication and caching, and especially with GraphQL, those are the two topics that we know that are very important, and a lot of people have trouble with it. And it's always, people are always talking about how to make that experience better. So I love
Mm.
that I love that part about GraphCache automatically caching after mutations. So that
Mm.
was super cool update.
Yeah, thank you. Yeah, it was like so in my application, it's like a fully fledged application. I think there were only 3 places where we had to manually update the cache. Everything else was done automatically. So it's a really nice user experience.
Absolutely. Would love to try it out myself.
Awesome. I hope you do. If you have any questions, obviously message me.
Obviously. Yeah, of course. Absolutely. All right. Thank you so much, Caddy, for that amazing talk. We have
Thank
been
you.
awesome. Now we have another amazing speaker, and at the risk of being a bit biased, I'm gonna say that I'm super excited for this one, especially. So I'll be calling on Praveen Durairaju from Hasura to give the talk on data federation with GraphQL. Hey, Praveen, please
Hey Vish.
take it.
Yeah, thanks Vish. Cool. So today I'm going to talk about data federation with GraphQL and Hasura, um, and a little bit of introduction about me. I'm Praveen Doriraj. I'm a developer advocate at Hasura. You can follow me on Twitter, GitHub, on these handles, Praveen Web. So today, data federation, right? So basically, you have data sources in multiple places, and any application requires like APIs to be communicating with multiple data sources. So in today's example, we'll look at a few sources like joining data from Postgres, using like an open API spec, which is like a REST API, probably get in some data from a CMS, and so on. So in a typical use case, you have all of these three different data sources coming in, and we'll see how we can use GraphQL to actually leverage this and make queries in a single API call, right? So typically you have consumers, which are multi-platform. You have mobile apps, you have web applications, and external third-party APIs for consumption. And GraphQL becomes that data layer, the query layer, and you have on the other hand the producers of the data, which is like the database or third-party APIs and so on, right? So there is some glue that connects both the consumers and the producers, which is basically the API layer, for which we're going to use GraphQL. Um, and you have a lot of internal services and external services on the backend. And GraphQL becomes that layer which actually talks to multiple data sources, and then presents a neat layer to the front end, right? So if you look at it here, there's a lot of things going on over here, a lot of data sources, but the consumers actually leverage the benefit of GraphQL by just making a query and then not worrying about what's happening at the back end, right? So, and the interesting bit is that different consumers will need different data sources, and different sets of data. The amount of data will vary. So it's pretty interesting to know that uh, any GraphQL client, any front-end client, be it mobile app or web app, they'll be able to actually specify exactly what they want depending on their particular use case, right? And the API still remains the same for all of these consumers. So in Hasura, where Hasura becomes that GraphQL API layer, which an app contacts. So let's say the app actually makes a GraphQL request to Hasura. Hasura basically talks to multiple data sources, like probably like microservices. You have databases like Postgres and like MySQL and so on. And you also have external SaaS APIs like Stripe, Auth0, and so on, right? And it could be your particular serverless function and so on. So a little bit of context how Hasura fits in here in the GraphQL space. So Hasura basically is a GraphQL layer which connects to databases and microservices to give you a real-time GraphQL API. And it comes in with built-in authorization layer, which gives you a role-based permission system that you can configure declaratively. And it's pretty easy to just do configurations and do migrations and so on, right? But for today's focus, we'll look at the federation aspect of Hasura, which brings in data from different sources and then actually merges them into one single queryable schema, right? So basically, Hasura contacts microservices and databases and external APIs, but then the client actually receives data in a single format, right? The query is basically the same, but the data actually internally Hasura basically proxies it to multiple sources depending on which part of the query needs to go to which place, right? So Hasura takes care of that, applies some authorization rules on top of them, and then sends back the response to the client, right? So I'm going to make this little demo driven to showcase what data federation looks like. So I'm going to create a project on Hasura Cloud to get started. And so for Hasura to work, you need a Postgres database to start with. Heroku gives you like a Postgres database add-on, right? I'm just going to use that to create a database. And once I get a database URL, Hasura just basically requires this database URL to connect to and then create a GraphQL API, right? So we'll let the app actually initialize for a few seconds. So basically, this is now deployed on AWS East region. Now I'm going to launch console. We'll give it a few more seconds for the DNS to reflect. So if you look at the GraphQL API here, we immediately get a GraphQL endpoint for consumers to start using it. And we look at how that can be used. So I have this Hasura console ready. So what we've done is basically we've deployed a version of Hasura on Hasura Cloud, and we've connected it to a Postgres database. Right now, it's a new database, right? And we've got a GraphQL endpoint which you can start using to query, right? What I'm going to do is for this example, I'm just going to create a couple of tables and then map some data from different sources. So for example, let's start off by creating a users table. Let's say I create a users table with columns ID and name, the typically used columns. I'm just going to use some defaults, and I'm going to add a table. So what this does is it basically creates a table in the database, underlying database in Postgres, and then this is just a UI to manage the underlying database, right? But the interesting bit is that once you create a table, you can see that GraphQL queries and mutation subscriptions are being generated. So I can now start doing queries on the table and the columns that I've created. Obviously, the data is empty, but the idea is that you've created a table and Hasura has generated the API for you automatically, right? So now, so this is the GraphQL endpoint at the top. Your front-end client can just directly use this to get data by making a GraphQL query, right? And on top of this, you obviously have authorization set up to prevent malicious access. So you can do that. But now switching back focus to the data sources. So I have this users table, but let's say the user table also has probably another column called, just for this example, I'm going to have a column called currency, which I'm going to fetch the data from a different source. Let's say it's not nullable. I'm going to add this new column. Let's say I add a user, and let's say the currency is USD. Right. So now my use case is that I have this data in Postgres, but I have some custom logic where I'll have to get the latest currency rates for the real-time currency rates, right, for the user, and the user's currency setting is USD. So I'll probably require the different values of different currencies, right? So what I'm going to do is I have like an Exchange API which is there open that I can use for free. This is the Exchange API that I'm going to use, and to do that, so this is the REST API, right? And Hasra basically requires a GraphQL API for a remote schema. So here, what we're going to do is we're going to create a GraphQL server, which can be added as a remote source, and then we'll start establishing relationships between multiple sources, right? So for this particular example, I'm making use of this open source package called OpenAPI to GraphQL, created by IBM. What this does is if you have like a REST API following the OpenAPI spec, um, you can actually like configure this OpenAPI to GraphQL library with that spec, and then it will try to generate a GraphQL API on top of that, right? So I have a boilerplate of that configured already. So I'm going to open this on Glitch. So this will have the source code for converting the currency API, REST API into GraphQL. In fact, not the resolvers, because that is taken care by the OpenAPI GraphQL library. So we're just going to pass the OpenAPI spec, and then the library will take care of generating the GraphQL API, right? Cool. So if I open the JSON file of the spec, you can see that I'm using this OpenAPI URL of exchange rate api.com. I'm going to use this spec, and then this would have actually created a GraphQL API for us. So if I open this in new tab, and then I do /GraphQL, if I go back to this code again, I can show you that there's an Express app running, which runs on /GraphQL endpoint. It serves the schema and the GraphQL interface, right? So this is the endpoint where I can now do a query to get the latest value for any currency. So let's say my base currency is USD, and I want the rates for today, right? So I get the data from this currency API, USD being the base. I have the conversions for the rest of the currencies, right? Cool. So now if I go back to the app, the Husser app, where we've created the users table with the currency USD. Now my front-end client needs an API which gets this data along with the conversion rate of the currency depending on each user. So what we're going to do is we're going to add this GraphQL endpoint as a remote source. So I'm going to add this GraphQL endpoint as a remote schema. So with the remote schemas, you can add external GraphQL servers which are running elsewhere, right? I'm going to call this currency API, and the URL will be the GraphQL endpoint available in Glitch. Cool. I can forward all headers. I'm adding the remote schema. Cool. So now I've added this remote schema. What I can do is I can now try querying that through Hasura itself. So So the query that you saw in the GraphQL interface previously, we can now do that query over here. So I can do the date and the rates. Obviously, this is again doing the same query, and but Hasura is now the layer where the front end actually communicates with, right? So now we have both the users table over here and the types from the remote schema API, right? So what we're going to do is we want to join data from the users table's currency column to the value of the latest conversion rates, right? So that I can make a single query to get this data. So to do that, I'm going to the users table and I go to relationships. I can add something called a remote schema relationship, but I'll call this as conversion rates. And I'm going to select the currency API as a remote schema. And in the configuration, I can just select the base currency type, which I'm querying for. And I'm going to map it to the currency column that is there in the table. So in our users table, we have the currency column, right? We're just mapping that column to be the argument for the base currency type. Cool. So I'm going to create this relationship. Now, what we can do is we can query this. We have conversion rates. We have the base, obviously, and the date and the rates, right? What this will do is this will make a query to fetch the currency. In fact, I can also fetch the name of the user to make it simpler. So these two columns are actually coming in from the database, if you're aware, and the conversion rates are actually coming in from an external API. But the fact is that we've made a single query, and Hasura basically batches and processes data, proxies it to the external API, and then gets back the response for the client, right? So if I go back to the data tab, I can actually like modify the currency, make it INR. And if I make the query again, this time the base currency has been set to INR, and you have the conversion with the rest of the other currencies, right? So now in a typical e-commerce setup, you might want to do like order placements and like join data from external SaaS services, right? So this is one of the use cases where you can like join data from a different SaaS API or external API. So we are using an open API for currency conversions. By basically converting them into a GraphQL API, right? But technically, you can write your own GraphQL resolver, which will map to a database call, or it could map to your REST API call, right? Because at the end of the day, Hasura actually requires just a custom GraphQL server endpoint that you can add as a remote schema. But in case you have a REST API that you want to actually add, what you can do is you can actually go to Actions. With Actions, you can actually create a custom GraphQL type and then map it to a REST API endpoint. And then the REST API handler can actually be the resolver for your GraphQL query, right? Or the mutation. Cool. So the first use case is that I have joined data from an external SaaS service. My next use case is to join data from another database. Let's say another database is actually just the data for that is served by Hasura itself. So what I'm going to do is I have another project. If I just refresh this, I have another cloud project, and I can just show you the tables there. I have the order table and the product table here, a typical e-commerce setup where you have products with the price, and you have orders being placed for products tagged to the user ID. Cool. So in a legacy setup where there are multiple databases doing different actions, you have or even in fact different databases, meaning not just Postgres. It could be like a different database like MySQL, where one particular set of data is being stored for a different reason, and because probably there are faster writes and probably faster optimizations available. So you use a different database for a different use case, but the final idea is to actually merge them into a single API interface so that the clients can actually start querying, right? So now what we want to do is we have the metadata of the user over in this table. This is the user ID column, and we have the users table in the other project of Asura, right? What we want to do is we want to basically merge these two databases. So to do that, I just need the GraphQL endpoint of the project. I'm just going to add them as a remote schema. I'm going to call this Hasura remote schema. And I'm just going to put in the GraphQL endpoint from Hasura. Right now, I don't have any admin secret configured, but in case I have an admin secret configured, I can actually pass in an Hasura admin secret as a header, and then this will be authenticated on the backend, right? Um, I'm going to add this as a remote schema. Now, if I go back to GraphQL, I can actually start querying for the order table from this, and I can do ID, user ID, and the product ID. This will give us some data from the other database. So if you note that this particular endpoint is a different GraphQL endpoint, and this one is a different project serving a different database, and this has a different data set, right? But the common element between these two databases is the user, which is mapped to the order table. So coming back to the relationships, I go to the users table here. I go to the relationships tab. I add another remote relationship. This time, let's say I have this relationship called orders. I can go to the Hasura remote schema. I can select the order, and I can do where user ID is equal to the ID of this user table, right? I can now click on save, and I have added a relationship called orders. So now I can query for users. I can call the name. I can even also get their conversion rates, which will have the rates. And I can also get the orders, which will have the order and the final price, and also probably the product ID. So we're actually fetching data from 3 different places here in a single query. If you look at this response, this ID and name of the users table is coming in from the users table in this particular database. The orders value is coming in from a different database, again served by Hasura, but it need not be served by Hasura. It can be any GraphQL server, and this conversion rates data is coming from an external SaaS service, right? So the whole idea is that you have data sources obviously spread out in multiple places, and your consumer, the front-end consumer, wants to actually access and query them in a single place, in a single GraphQL query, and this is basically totally possible because of the schema, the type system that GraphQL exposes, which enables this sort of tooling to be done, and this sort of nested queries to be made. Obviously, you have to be careful about how deep your nested query looks like to optimize for performance. But in most app use cases, you will want different data sources to be merged into a single API call, so that now this will reduce the number of round trips on the front end, but technically it's done on the back end. But the consumer basically doesn't care. The client, which is basically the web app or the mobile app, it doesn't care about how many API requests are being sent. So that's pretty much this data federation demo. I have another small demo if I have time. I think I can do this as well. This is an interesting experimentation that I was doing last month, where I have this GraphQL endpoint served by Gatsby. So if you're familiar with Gatsby, it's just a React static site generator, which has a GraphQL data layer, um, and and it is served in a development environment. But in a production environment, you see that it's a static site and it just outputs HTML that you actually end up putting on a CDN. But the fact is that there is a GraphQL data layer in between, right? We're going to just basically leverage that with the source plugins that Gatsby has. Gatsby has this bunch of source plugin ecosystem where there are different REST APIs being merged into a single schema into Gatsby. Um, so what this means is that if you've written a plugin for Gatsby as a source plugin, and then you've been probably using it, you can actually now use the endpoint that Gatsby exposes on the dev server, and then actually try to use them for a production environment where you have different data sources coming in, and then you're actually stitching it into one place, and then you actually merge them into a single endpoint, right? So this is one of the API servers that I've deployed on Heroku. This is just a Gatsby app. It's a Gatsby Node app. I've just deployed this here. If you're running Gatsby on a local development environment, you will note that it exposes triple underscore GraphQL endpoint, where you can actually just query this interface, right? So I have this example where so there are a bunch of default plugins which Gatsby exposes, the source file system, for example, and I've added like the Git source file system, Git source plugin, which lets me query some Git remotes by just giving in the name of the repo, and it gives some details about the organization and so on, right? Just as an experimentation, we can actually copy this GraphQL endpoint served by Gatsby, and I go to remote schemas, and I add this remote schema called Gatsby, and I add this GraphQL endpoint. I can forward headers. If you have like an authenticated API in Gatsby, you can forward in different headers or credentials and secrets, right? Cool. So now we've added the Gatsby endpoint. Let's see if we are able to query the Git remote, and you can see that it's all added on the Explorer. So the schema is now merged into a single data source. So I can actually make the similar query that I have here. Just copy this, and you have data coming in from Gatsby now. So if you look at the whole demo, we've actually covered like an array of data sources. If you look at the schemas that is generated now, you have types from Gatsby. You have types from two different databases served by Hasura, and you have an external SaaS API, which is just doing a simple currency conversion. But you get the idea that this can technically be anything. It could be like your payment service like Stripe, and you can add any data source which can be just queried on and then merged and into a single query, right? So that's the whole idea behind data federation. The whole idea is just data sources are in different places, and you want to actually now query from different consumers a flexible way to actually query your data, right? And Hasura provides this neat abstraction where you declaratively configure different data sources, you add them, and it also adds an authorization layer on top. which will actually make it pretty easy for the front-end client to start querying. So to quickly go and show the permission system. So I have this users table, and I have this permissions tab where I can define roles. And what this will do is, if you have an authentication provider integrated, you can now specify it either in a JWT claim or in a custom webhook where you can just validate the request. You can actually specify what kind of operations a particular user is supposed to do by just doing some checks on whether the ID of the user has to come from some variable, or if some column has to have some value, right? You can do all sorts of checks here, and you can select exactly which columns you want to expose it to the front-end client, right? So this makes it pretty easy to set up authorization. This is also pretty declarative. You can use the YAML configuration in the CLI if you prefer that way, or if you just prefer the GUI, you can use this console to declare permissions. Um, and I think what is pending, or what is more upcoming in the upcoming release, is that now that you've joined data from different sources, um, you will want to also now granularly specify permissions for the remote sources. Right now, if you look at the permissions can be set for the current data source. Obviously, there will be permissions for the other Hasura database, which has the users and orders table, and you can forward in the headers, which will take care of the authorization setup for this database. But if there is a way to actually set up permission system for different remote schemas granularly at a node level, that is what we'll be adding pretty soon. That will make it pretty cool to actually now use any API, and Hasura becomes that app app and the database, the interface for the app and the database, or even any microservice, right? So that will basically just turn Hasura into that powerful API system, which will proxy to different APIs and also be pretty secure and reliable for you to use it in production, right? So that's mostly it for my demo, I guess. If there are any questions, I can take them.
Awesome. Let's see if we have any questions in the comments. Oh, by the way, that was an amazing talk, Praveen. Every time someone gives such a cool demo, like a live demo or live coding, it just blows my mind. So that was a
Yeah.
that was a very pleasant experience.
Yeah. In fact, I think the first two talks were pretty amazing. I initially missed the first few minutes for the Alex's talk, but it was pretty insightful in the sense of uh, what uh, what kind of people you need to convince to actually use GraphQL in your organization. That's a pretty important step to for the adoption of GraphQL in general. So that's a pretty insightful talk. I would recommend people who have missed it to just check that out. And for Urkel, I think Caddy did a great job with the presentation. There's a lot of fancy pipes and exchanges going on. So I really want to try out the offline cache that
Yeah.
Urkel has. That'll be pretty cool to build offline first apps with Urkel and GraphQL. So that is something that I want to try out. I'll probably check it out pretty soon.
Yeah, absolutely. It was an amazing, amazing lineup of speakers, including you. And I love that part where Caddy was like, "Surprise, surprise! The DevTools is an exchange." That was hilarious. But yeah, even Alex's talk was a great primer to a GraphQL meetup. And so yeah, that was an amazing lineup. So, with that, we come to an end to this wonderful event. We had a great time. Thank you, everyone. So, if you have any more questions for our speakers, and even if you want to just say hi and take up any discussions on interesting topics around GraphQL, please feel free to reach out to them on their socials. And my brain is full of information. So before that becomes an information overload, I'd like to go ahead and process it. And I had a wonderful time with everyone and hope you did too. Bye, everyone.